Welcome students once again to GS Maths. Today I am going to start a new chapter, inverse trigonometric functions of class 12th, that is plus 2 class. Now I have written some functions, their domain, their range, their principal value branch. It's basically inverse functions, that is y equals to sine inverse x, y equals to cos inverse x, y equals to tan inverse x, and so on. Now the function is sine inverse, so its domain will be minus 1 to 1, range will be minus pi by 2 to positive pi by 2, and the principal value branch will be minus pi by 2 less than equal to y less than equal to pi by 2. That means the branch, whatever is the angle must lie in between minus pi by 2 and pi by 2. Similarly, cos inverse, its domain is minus 1 to 1, its range is 0 to pi, the 0 less than equal to y less than equal to pi is its principal value branch. Now where y equals to cos inverse x. Now tan inverse, all the real numbers, all the real values, its range is minus pi by 2 to pi by 2. Again the same thing, y equals to tan inverse x. Now cosecant inverse minus infinity to minus 1, union of 1 to infinity, right? Then minus pi by 2 to pi by 2, minus of 0. Why I have written 0? Because sine of 0 is 0. Cosecant is reciprocal of sine, which means it won't be defined at x equals to y equals to 0. So I have written here the function is y equals to cosecant inverse x, where y is not equal to 0. Its principal value branch is minus pi by 2 to positive pi by 2. Now, fifth is secant inverse. Again the same thing. Its domain is minus 1, minus infinity to minus 1 and 1 to infinity. Now 0 to pi is its range except for pi by 2. Why it's pi by 2? Because cos of pi by 2 is 0. If I take the secant, then it won't be defined at pi by 2. Therefore, y should not be equal to pi by 2 when the function is y equals to secant inverse of x. Its principal value branch is 0 to pi. Right? The last one, cot inverse. Again, all the real values, all the real numbers, that is the domain, range is 0 to pi, and its principal value branch is 0 less than y less than pi. That means the value lies between 0 and pi, where y equals to cot inverse x. This is the table you must remember, that the function is if sine inverse x, principal value branch is this, cos inverse x, then the principal value branch is this, tan inverse x, then the principal value branch is this, and so on. Now I will do few sums. How do we know principal value branch? What is the concept we will use? Where we will use this principal value branch? Now look, I will solve a few questions for you. Remember this table as such. Make a table of it and do write it once or twice so that you remember the principal values of inverse functions like sine inverse, cos inverse, and tan inverse. Now question is, say evaluate the following. Question number 1 is sine inverse sine of pi by 3. Now the principal value branch for sine inverse x is minus pi by 2 to pi by 2. Now this angle sine pi by 3. Pi by 3 lies between minus pi by 2 to pi by 2. Therefore, sine inverse this and this cancels. The answer is pi by 3. What I did, pi by 3 belongs to minus pi by 2 to pi by 2. The principal value branch. Therefore, they get cancelled. In general, sine inverse of sine theta, this is equal to theta if theta belongs to the principal value branch. This is the function of the branch, principal value branch, which I discussed just now. Now sine inverse of sine theta is equal to theta only when theta is belongs to minus pi by 2 to positive pi by 2. Now say tan inverse, if it is question is like this, tan inverse tan 3 pi by 4. Okay, now the principal value branch for tan is minus pi by 2 to positive pi by 2. This is 3 pi by 4, that is 135 degrees. Now what should I do? It can be written as, I cannot cancel them out, I have to bring this angle between minus pi by 2 to positive pi by 2. Right? Now, can I write this tan inverse tan of pi minus, this is 180 minus of 45, like this. This becomes tan inverse tan of pi minus pi by 4, that is negative. I can write this as tan of negative pi by 4, because tan inverse tan cannot cancel out here as such. So I have converted this into, I want to bring this theta in its principal value branch. So 4 pi minus 3 pi is 3 pi by 4, it's same. So tan of 180 minus theta, it's the second quadrant, it's negative. Moreover, we know tan of minus theta is negative tan theta. Now minus pi by 4 belongs to this branch, therefore they get cancelled. The answer is negative pi by 4, because negative pi by 4 lies within the principal value branch, that is minus pi by 2 comma pi by 2. This is the basic behind the principal value branch. Now next is, say, sine inverse sine 2 pi by 3. Right? Now this sine inverse and sine cannot cancel out. Why? Because 2 pi by 3 does not belong to minus pi by 2 to pi by 2, does not belong to the principal value branch. Now what should I do? This is 120 degree. It's very simple. If I write this as sine inverse sine 180 minus 60, this is 120. So sine of 180 minus is sine of pi by 3. Now I can cancel them out. The answer is pi by 3. Why? Pi by 3 lies within the principal value branch. Is it okay? I think the concept of principal value branch is clear to you now. You can try a few sums from this topic given in your book. Now, again I am saying, you must remember the table of the principal value branch of different inverse trigonometric functions like sine inverse, cos inverse and tan inverse. Now, your next topic is again based on the formulas of trigonometric functions which we have studied in +1 class. Now, say suppose it's written express tan inverse cos theta upon cos theta minus, let me write it, cos theta 1 minus sin theta in simplest form. Reduce this tan inverse of cos theta upon 1 minus cos theta in its simplest form. Now remember the formulas, we have to recall the formulas. How can we solve them? This tan inverse cos theta can be written as cos square theta by 2 minus sin square theta by 2 divided by 1 minus sin theta. Now 1 minus sin theta is cos square theta by 2 plus sin square theta by 2 minus of 2 sin theta by 2 into cos theta by 2. cos theta का फॉर्मूला, cos 2 theta का फॉर्मूला क्या है? Cos square theta minus sin square theta, angle becomes half. Here it was cos theta. Now it is cos square theta by 2 minus sin square theta by 2. In place of 1, I have written cos square theta by 2 plus sin square theta by 2 minus of 2 sin theta by 2 cos theta by 2. Now tan inverse, make factors of it, a plus b into a minus b, a plus b into a minus b, a minus b divided by, I can write this as a perfect square of cos theta minus sin theta by 2, its whole square. Now one of the factors cancels, I am left with cos theta by 2 plus sin theta by 2 upon cos theta by 2 minus sin theta by 2. Now tan inverse, divide the numerator and denominator by cos theta by 2. It becomes this. Now what is the formula of this? This formula is tan inverse 1 plus tan theta by 2 upon 1 minus tan theta by 2. This is tan of pi by 4 plus theta by 2. This cancels out. Your final answer is, in the simplest form, it's pi by 4 plus theta upon 2. This is the simplest form. I have reduced this expression into the simplest form. This pi by 4 plus theta by 2. Now, there are some methods or substitution methods in which you have to substitute the given expression or the given variable. Now, let me write down. Now, expression can be say a square minus x square, right? So we can substitute x equals to a sin theta or x equals to a cos theta, right? If the expression contains a square plus x square, now I know कि secant square theta equals to 1 plus tan square theta, so secant square theta equals to 1 plus cot square theta. So I can replace this x with a tan theta or x equals to a cot theta, right? This is a square minus x square, a square plus x square. Next will be say x square minus a square, x square minus a square. Now I know secant square theta minus 1 is equal to tan square theta. So I can put x equals to a secant theta or x equals to a cosecant of theta. Why? Because cosecant square theta minus 1 is equal to cot square theta. Similarly, if I have an expression like this, a minus x, a plus x under root, or it's a plus x upon a minus x. So I can put x equals to a cos 2 theta. Now put x equals to a cos 2 theta. The last one is a square minus x square, a square plus x square under root, or a square plus x square upon a square minus x square. Now put x equals to a square cos 2 theta. That is x square equals to a square cos 2 theta. It will become much easier to solve the expressions or to solve the inverse trigonometric functions containing the expressions these, this, or any one of this. So substitute these values. Substitute. We can substitute these values. If the expression has a square minus x square, yeah, inverse trigonometric function has an expression of a square minus x square, then substitute x equals to a sin theta or x equals to a cos theta. If the expression is a plus x, a minus x under root, we can put x equals to a cos 2 theta. If the expression is any one of them, then we can put x square as a square cos 2 theta. Now I will do few questions from this also. For example, remember these criteria for substitution also. Now the question is tan inverse x upon under root of a square minus x square. tan inverse under root x upon under root a square minus x square. We have to reduce this expression in simplest form. Reduce in simplest form. Now the expression contains a square minus x square under the root. Now what we can do is we can put the value of x square as x square. This is a square minus x square. ठीक है, under root. So we can put x equals to a sin theta or cos theta. It is better to put sin theta. Now what happens? I can find theta from here. X upon a is sin theta. The theta equals to sin inverse x upon a. This. Now tan inverse x की value a sin theta, right, upon under root a square minus a square sin square theta. Now this is tan inverse a sin theta upon a square is common in these, so a will come out. 1 minus sin square theta is cos square theta, so only cos theta remains. This goes. So tan inverse tan theta. This cancels out. We are left with theta. Where theta की value क्या है? This. Theta is sin inverse x over a. This is the simplest form of this expression. Remember the criteria for substitution. The inverse trigonometric function contained an expression of a square minus x square under the root. So what I have to substitute? X equals to a sin theta. ठीक है? तो a sin theta divided by substituted, I get tan theta. Tan with tan inverse goes. Theta is left, but where theta equals to sin inverse x over a. So the simplest form of this expression is sin inverse x over a. Let me try a few more questions. Now, question is tan inverse a minus x upon a plus x. Tan inverse a minus x upon a plus x under the root. Now, what is the substitution? What I have to substitute for x, right? You can study the table, then you can remember what I have to do is. Now the expression is a minus x upon a plus x. It's clear that I will put x equals to a cos theta. That is x over a is cos theta, or theta equals to cos inverse x upon a. Now this expression tan inverse under root of a minus x, a cos theta, a plus x, a plus a cos theta. It's this. I get tan inverse a cancels in the numerator as well as the denominator. What I am left with? 1 minus cos theta upon 1 plus cos theta, right? So this. Now tan inverse 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2 within the under root. This cancels out. 2 with 2 goes sin square theta upon cos square theta by 2 is tan square theta by 2. When it comes out of the under root, I am left with tan inverse tan of theta by 2. This cancels out. Theta by 2. So theta value is cos inverse x over a. So I get the final answer as half. Theta is cos inverse x upon a. This is the reduced form of this inverse trigonometric function, that is tan inverse a minus x upon a plus x under the root gets reduced to half It's the simplest form, half cos inverse x over a. Hope this concept is also clear to you, but I'm again repeating, you do remember the substitution criteria, okay, how and what we are going to substitute in place of x or any other variable or any other value. Right? Now, next topic is just like this thing. Evaluate the following, that is sine of sine inverse 5 by 16, that is cos, say evaluate sine inverse of cos, say 5 by 13. Right? Now remember this thing, is sine inverse perpendicular over hypotenuse is equal to cos inverse base over hypotenuse is equal to tan inverse perpendicular over base, cot inverse base upon perpendicular is equal to secant inverse hypotenuse upon base is equal to cosecant inverse hypotenuse upon perpendicular. Remember this, sine inverse perpendicular over hypotenuse is equal to cos inverse base upon hypotenuse is equal to tan inverse perpendicular over base, cot inverse base upon perpendicular, secant inverse hypotenuse upon base, and cosecant inverse hypotenuse upon perpendicular. This is the right angle triangle. This is perpendicular, this is the hypotenuse, this is the base, this is the angle. Now sine inverse of this is equal to cos inverse equals to tan inverse equals to cot inverse equals to secant inverse equals to cosecant inverse of hypotenuse upon perpendicular. Now in order to solve this, what I have to do is I have to convert this into sine. Okay, solve the right angle triangle. Now just this 5 by 13 cos base upon hypotenuse, that is 169 minus 25, 144 square root is 12. So I can write this as sine inverse cos of 5 by 13 is, I can write this tan sine perpendicular over 12 by 13. This cancels, the answer is 12 by 13. Right? Now, one more question please from this very topic. Say sine of secant inverse 17 by 15. Sine of secant inverse 17 by 15. 17 by 15. This thing. Right? Now sine inverse secant, sine of secant inverse 17 by 15. Now I am given secant inverse hypotenuse upon base. That means a right angle triangle is there. Secant inverse is hypotenuse upon base. This is the hypotenuse, this is the base given to me 15. Now just calculate the perpendicular. This is hypotenuse, this is the base. I want to calculate the perpendicular. It is 17 square 289 minus of 225, that is 44. Right? 44 1, this is 225. So this becomes 289, 17 square minus 225, that is 44 is left, the 64 is left. So perpendicular becomes under root of it, it comes out to be 8. Perpendicular is 8. Now convert this secant inverse hypotenuse upon base into sine inverse perpendicular over hypotenuse. So I get sine inverse perpendicular 8 upon 17. 8 upon 17. This goes, I get 8 upon 17 is the answer. Now this was the first topic of the chapter inverse trigonometric functions for class 12, right? Now I again repeat, remember the principal value branch table in which sine inverse x, cos inverse x, tan inverse x, cosecant inverse, they lie, right? Then remember the substitution criteria. If the expression contains a minus x upon a plus x under root or any other expression, what and how we have to substitute the value of x, that is x equals to a cos theta 2 theta, or x equals to a sin theta, or x equals to a cos theta, and so on. The last I discussed this is sine inverse p by h is equal to cos inverse base upon hypotenuse is equal to tan inverse perpendicular over base, and so on. Hope you have understood the topic, right? In my next lectures, I will continue with this chapter inverse trigonometric functions by solving more questions and telling you more concepts and more formulas which will be applied. Thanks for watching my video. Keep working hard so as to succeed. Stay safe, stay healthy. Thank you.